Hi everyone. So in this second part, I'll be looking at instead of creating the Cosmotron control plane pod manually, not entirely manually, but I mean, if we can make use of FLUXCD, just like to give you some a bit of like the Gitops experience, right? So the FLUXCD will be doing all the infrastructure deployment that we'll be using for this video. So I'll not be going through the actual installation of FLUXCD or the Terraform controller. You can check the documentation and also the GitLab installation. There are a lot of there are a lot of tutorials about this also. So, but I'm having this as a single VM instance. It's on-premise just for my lab, and then also this, of course, the FLUXCD is running in a Kubernetes cluster. So in the same Kubernetes cluster, the FLUXCD is going to create the Cosmotron uh, cluster, and then that's the control plane pod, and then it will proceed. After it's done that, then we'll retrieve the token and all the likes, and then we will now go about to create the worker node VM on ProxMox also, but then we'll be using the Terraform controller with Flux. So you create the Terraform resource, you commit it to the GitLab, and then the FluxCD will trigger and apply it to the cluster, and then the Terraform controller will pick it up and then create the VM in ProxMox, and then via the user data, the ProxMox will now download uh, the KOS binary and then connect to the back to the cluster. To the control plane. So in my GitLab, I have two repos that I've already created, and also even though you are seeing this like as being let me increase this. So even though this is showing like looks like it's on the internet, actually the behind the scene I'm using nginx proxy manager, whereby this particular URL is actually pointing to my private network, right? So we can give it a try just to see if you do a post for that for that URL, you will see that it's actually returning a private IP, and it's a full. It's we are using Let's Encrypt via the nginx proxy manager. This is not super important, but then it's always good to have a clean SSL, TLS configuration. And I truly appreciate what the nginx proxy manager does. I think you can use other softwares like you should be able to use like Traffic, right? Traffic too might be able to do that, but the nginx proxy manager makes it a bit easier. Uh, so this is what I will not be using SSH to connect to this cluster. Just for your information, I'll be using the token to access this and then to do the push and all the like. So this will be this is the one that Flux actually used for the installation. And then if you go into this, you actually see that Flux is using this to initialize itself via the Flux binary. All right. So once it's done, uh, the the other the other repo here, you can see is blank. This repo will be used to host the the actual. First of all, there are two parts to the ProxMox part. That's the VM. Creating this VM, you need to create a Terraform custom resource, and also you need to create the actual. Uh, you have to create the actual part for the Terraform files itself. So there are a lot of processes. If you are not familiar with how FluxCD works, there are a lot of other tutorials that can give you an overview of that. So that's why I don't want to like go into the details of FluxCD. There are lots of tutorials on the internet for that. So the first thing we'll do is we'll create a Git repo resource. that will that we are going to use. That we are going to create a Git repo resource for this second repo, because that's where we'll be pushing our stuff to. I mean the Terraform files. So yeah, I'm in that repo. So I have some. Just have some files I created already. So if we check the cluster resource, so you see what it's doing. You can see here that we're actually pointing to to the to the uh, to the repo I mentioned. This is where we'll be storing the Terraform resources, and then I will be calling it K0smotron, right? So before we do that, if we do a git repos -a, so we see that it's only one, and that one is the one that Flux created. So if we do a git status to add the second repo, we can see that that's there. So we do a git add cluster resource, then we do a commit add git repo. Oh, yeah. Then we do a git push. So essentially, time we should be able to see this Git repo after a short period of time. We could also check there is the actual pod that watches that is called. And see here you have the source controller. So if you do the logs for this, you should be able to see some interesting thing that has to do with what we just applied. So here you can see that yes, it's saying that there is a new Git repository. The namespace is this, and this is the name. So that means it has already reconciled. But let's see from here whether we see it. So you can see that we have the second Git repo, and then you can see that this just been created. So if we go back to our this, so we'll see that we have this cluster resource. So this has been done. So the next thing we need to actually do is to create the control plane pod. So I've already installed I've already installed the operator, the K0smotron, like the operator, right? So the only thing we need to do is to get the custom resource and then add it to the cluster. So let me check some of the. So now, so yeah, so the test manifest is what we are going to use. So if we do this and then let's see what's inside that. So yeah, you see that now it's an interesting thing here, right? So you see here we are creating even though we are the K0smotron installation itself, it's a simple YAML file. So it's not really a customization or a Elm file. But from the documentation of FLUXCD, it says that if you want to create a simple Kubernetes YAML file, you still need to create it as customization. So that's why we are calling it a customization. And you see there that we're actually putting it here, that we are referencing the other Git repo that we just created. Now we are also looking at where we should be looking at. We should be looking at the manifest file. Okay. Now this is not currently existing. So essentially this might even it might not it might not really work, right, if we don't put anything into this manifest. All right. So there is either way you can commit this change, and then if you commit it, you will just see that it's going to say, okay, this part does not exist. Or we can create this part in the second repo first, and then see how it reacts. So, but then let's just let's take it step by step. So let's create the folder there, so we can say we don't have we don't have the manifest folder. So we can create the manifest folder, all right? And even as we create the manifest folder, we can go ahead to add the actual template that we want to use for the K0smotron control plane. So in part of the let's see so if I go into the manifest list, so we can see that that's the test K0smotron. So let's just copy that to here. So, and then let's see what's inside there. So you see, it's a very simple CR custom resource. We're saying kind cluster, and then we are giving it a name. So that means it's going to create this in the default namespace. So what we are doing is we are preparing the application. We're actually preparing this GitHub repo. We'll commit everything there, right? And once we've committed, then we'll now go back to create the customization that will now reference it from there. So if we do a git status, so that's just what we just did. So we do a commit from cp. Okay, so we do a git push. Nothing happens because we don't have anything to say that, okay, like I said here, we will need to commit this. Once we commit this to the parent, to this where was I? Yeah, to this repo here, then it's going to reference the application repo, and then it's going to check into the manifest, and then it's going to apply the cluster. But then let's see if we don't have any cluster resource currently. So we see we don't have anything there. And so what we just need to do is to go back to the original GitHub repo where Flux was initialized. So if we do a git status, so we see that we've added this manifest file. And like I said, this manifest file is only doing one thing: it's creating a customization, and then it's going to apply whatever that is in this manifest file. So let's do a git add, and then we also commit that. Okay, so we do a git push, and then we could also we can also see that there is a customized controller. So this is the one that will get triggered, and then we can see if it's able to pick it up. So we'll see, yeah, so we can see I think it has picked it up. So we see a reconciliation as it. Let's see again. Trying to look for. Okay. Let's get the chapter. Let's see if it's yeah, it's created, but I was trying to see if we can get. Okay, yeah, I was not. Where I was too fast there. So you can see here that it's saying customization, and it's saying K0smotron info. That's the name we gave that particular. So if we go back to we go back here, so we see that we have this manifest now. You can see the name is this, which matches what we have in the logs here. You can see the namespace is this, and at the end of the day, as you can see, it has actually created this in the cluster. So as per our diagram here, you can see that this is done. So the CP pod is created. You can do a get pod for that. So you see the stateful sets. You can see that this has been done. So the next thing that we need to do is to create the worker node, and then we have to go all the way through using Terraform. So Terraform for ProxMox, the provider we are using is called Telemate. So it's one of the popular provider, I think, that is being used for Terraform for ProxMox. So also going through that, it will take lots of another set of videos. So you can try it out. And like I said, this is because I'm having ProxMox. You could, maybe in your environment, you're having VMware or some other OpenStack or whatever platform you are using for your hypervisor or your cloud. So here you can see that we are just creating this, the target node. These are specific to this Terraform provider. And interesting part will be, okay, we are creating this number of cores, we are setting up this disk, the network. Then we are interesting. One of the most important parts will be this. This is, if you are used to cloud platforms, you have what we call your user data, right? Or your cloud init script or whatever. So this is where it goes in. But this is interesting because this has to be on the ProxMox server. So if you want to make this more dynamic or more automated, you can actually use the Terraform file provisioner and to actually get the file maybe in your local machine and then push it up to to ProxMox. But I'm not doing that. I'm just creating this directly in the in the ProxMox server, and then we can have a look at the ProxMox server also. So this is my ProxMox server. Let's increase it a bit, and then if I do it, so you see this is what essentially will be called on when that VM gets created. So you can see the host name, SSH keys, and now this is the interesting part whereby we do the actual KOS installation. We do that, and then this token is something that also needs a bit of explanation, because for this token I'm actually pulling it from this server also. The IP address of this VM is .3, okay, 100.3. This is not ordinarily, this is not the best way to do. You could make use of Vault, but then I see that it was taking much of my time just to get this demo working. You can actually make use of maybe Vault or the Vault agent or about to pick up this token after you've created it, commit it to Vault, and then retrieve it. You can do that, but maybe I will have another video for that to see how you can do that securely, because you have to look at it that so that because you'll be needing some form of credentials, and at the end of the day, you might, if care is not taken, you might even be exposing much more than what you are doing for this token. Another thing that we could do is we can also look at it if this token has, I think K0smotron, maybe it should be possible whereby you can give a time value for this token once it's used, maybe for some minute, or even when it is used, you can go ahead to delete it from the control plane once this worker node comes up. And once it's done, then that's it. Then you might have you might have just removed that barrier. So that's what we are trying to do. Once we get the token, then we now do the initialization, and then we now do the KOS start. So that's for the user data script. So that's what is here, and that is what will be run once this VM comes up. And then you also have the IP address, which are part of the variables here. So you can see here that this is the IP that's going to be set there. So that's that for the Terraform. So the beauty of it, like I said, is that this will be done directly from FLUXCD. And if we look at our ProxMox environment, we can see these are the list of the VMs that we have currently. And at the end of the day, what we are looking for is to have a VM that has the name this K0smotron Worker. So currently we don't have K0smotron Worker here. So you can look at it. We don't have it. Once it's done, then we'll have it in the yeah. So the next thing is we need to generate the worker token. I mean the joined token. So here we can have a look at the K0smotron web page. We go here, we can see this is the command. So we can just copy this since we already have the pod running. So we can do the exec. Now we have KMC. Then this. Okay, so we have the token generated, and then I need to put this because I'm running nginx on this VM. So we can go into and first of all null it. So this is under HTML and token. So let's go ahead and do trying to null that. Then we copy this. Then paste. So that's done for the token. So the next step is to actually create the Terraform files in the Git repo. And so if you remember, this is we pointed to this repo here, and if you take note, if you come back to this, you will see reference to this Git repo here. You can see it that this is actually the Git repo here. So you can see it's KOS, and then this is the repo it will be looking at, which is the second the other repo that we have. So if we come back here and then go to this place, this is where we need to actually push. We need to add the Terraform files into this part. So let's see. So let me confirm again if part we are going to use. So yeah, so the part will be slash manifest. And then first of all, we need to also create a Terraform. Yeah, I nearly forgot that. So we need to create a Terraform resource, right? Custom resource is this Terraform custom resource that will reference the what do you call it? That will reference the Git repo that we've created also. So for that, we can also create it within this repo. So we can see that it's a Terraform resource, and we are giving it a name of this, and then we are referencing the same Git repo the Git repo that we created. But now look at the path that it will be looking for. It will be looking for this, it will be looking for the Terraform file in this K0smotron worker file, not the manifest file. So I'm sorry about that. So we create this also, but then, like I said, nothing will come up. So the best bet we can do is let's go back into the application repo and then add a folder to it. So if we do a make there and then copy over the Terraform resources just into this. So we do this backup and do start.tf. Let's see what's there. Okay, I'll pull that there. So let's see this if we have everything. So we still need the TF So the TF has what do you call it? Some of the information to connect to the ProxMox. So like I said, ideally you shouldn't be committing this to your Git repo, right? So you might, like I said, you might have a means to expose some of these secrets, right? Even FLUXCD has that implementation. So in your Terraform custom resource, you could be able to have some other values here, even include your VAS file, directly in your Terraform custom resource. You can do that. It depends. I don't want to keep this too complicated, but all those things can be done via your Kubernetes, maybe config maps or secret also. So as that is done, so we can do a git status also. So we see we have that file there. I mean that the folder. So if we do a git add, so then we do a commit. Then we shall say add left. We git push. Ordinarily, this will not do anything because we have not created the custom resource for the Terraform. So for us to do that, I mean, just to confirm, we see if we do a get Terraform infra, okay, so we see that we don't have anything there yet. So we switch back to the other folder again, to the one that we want to use for the, let's see, I think we already added the file there. Okay, yeah, so we already added this file. So if we commit this file, what happens is that it's going to look at, for this, what we just committed in the second Git repo, it's going to look into it and pull the Terraform resources, right? And then it's going to apply it to the cluster, I mean, to the ProxMox, right? So let's add that also. So add TF custom resource, and then we do a git push. So like I said, if we go to the Terraform, I mean to the ProxMox, we'll see that we don't yet have any new VMs, or so to say. So soon we will have something like that that will show up. And take note, in our Terraform resource, we're actually saying approved plan is auto. That means we don't need to do a manual approval. And then I'm disabling drift detection. You can choose any other option that you like. And I'm also choosing destroy resource on deletion, so that when this CR custom resource is deleted, then ProxMox, the Terraform controller should delete the virtual machine also. So you can see here that we have the virtual machine being created. So we see it's still coming up, right? So after a while, it will come up, and then we can even SSH into it and see the status of the K0smotron. So in a little while, we will see that this will actually start up by itself. You can see that we didn't create anything directly from ProxMox itself. So we'll wait a bit for it to do its thing. Okay, so you see that it's coming up. So it's booting up. It's reading. It will be reading the cloud init or the user data files, and it's going to be doing a lot of I mean the what we want it to do. So to show you the let's get the Terraform resources again in this cluster, so we can see here that it's actually saying that okay, that we have this, right, and then it's saying status applying. So you can also look at the logs of the Terraform controller if you want. So, but if we continue to tail this, we'll see. I mean, if we do a watch, we'll actually see that it keeps on saying it's applying. And soon enough, if everything works well, I mean, we will see the status to be what do you call it, to be in the ready state. So the IP that we provided this VM is I think .21, if I'm not mistaken. So it's .21. So we can SSH into this from our local machine here. So that will be Ubuntu, and you should be able to access it because we are using the SSH keys has been injected. So you see we are now into the VM that was created by the Terraform controller. So we could also take a look at the cloud init logs. So we see this the output to see if everything also went well. So we see here that fine, we have yeah, you can see that it's actually pulling the KOS binary and it's putting it in user local bin, and then for you could add some more login options to see if it was actually able to run the KOS join command. So, but for that, we could just do the status to see if we were able to communicate with our control plane, and truly we were able to do that. So, like I said, all this now was done from the perspective of Gitops, right? And then if you come here, you can see that Terraform says applied is true. And if we exec into our control plane port, which is and then we run the kubectl get remote -o right. So we see here that it has added the worker node to it. So we can see here it's saying not ready, and then the age is 78 seconds. So gradually, I mean, you can see that also this also matches we're actually using our Ubuntu image for the VM, and after a while we can check the pods. We see that the pods also are coming up. So we can see the proxy and the CNI pods are up. Then the remaining pods are the core DNS and then the metric server. So also from here we could because it's using container D, and KOS did something that's very good. I mean, they already have the tool for you to actually inspect the images. So since this is not this is no longer Docker, right? So you can see this is containerd. So the tool that you are going to use to list the images is going to be different. So I'm not sure, I can't remember what this tool is actually. Maybe it's native to KOS, but I know there is a particular tool also that you can use to interact with your what do you call it, with your um, which are container D images, or as the case may be. Also, I think we can do container this. Yes, I can do container ls2, so we can see that these are uh, the uh, the containers that are already running in this worker node. And if we come back here, we should be able to see that all the pods are up. And then if we do a get node, it should be in ready. So to also confirm to you that we have everything up and running, you can always run a test and then use the nginx as a test pod, just to see if we can make use of our cluster. So if we do a get pod, you can see that's in creating. So let's wait a bit so we can see that the pod is actually running. And like I said, you can do everything that you can do on that pod. So you can just do the test also to see that it's actually running. Do the coil to the local host, and there you have it. So everything runs end to end. So in summary, I know this is a bit of a long video, but I hope it's worth it. It's something that you can also try it out for yourself. So we can see all the way we have, like I said, we have our on-prem GitLab, we have the FLUXCD, we have the Terraform controller. The FLUXCD was used to create all these resources, including the virtual machine on ProxMox, and also to instantiate the kubelet to join the control plane pod. So I hope this was interesting to you also, just like it was interesting to me, and I hope to see you in the next video. Don't forget to give us a like or subscribe, and also share with those you think this video might be useful to. Thanks. I'll see you in the next one.